Hi, my name is Aniket. I'm a professor at Purdue University, and I'll be talking about the work on secure allegation escrow, which is highly related to Callisto talk that we just heard earlier. And thanks a lot for this opportunity. And it's fascinating to hear lots of very interesting talks in this space, and it's great to hear about all the interesting directions here. At Purdue, I run a freedom flag where we look at interesting problem with respect to privacy, as well as the freedom of expression, accountability. And today I'm going to talk about a specific thing that I worked on a couple of years ago. But when I saw the call come up, I found that to be quite appropriate, and I am going to talk about it today. Okay, so I need not to say here in this ground that there are just many crimes, especially of the sexual nature, that goes underreported. Um, I'm pretty sure all these statistics and things must be known to this community. So I'll directly come to the point that indeed we need solutions like Callisto, which are and it's great to have that, which can actually provide some guarantees and provides some medium for people to come forward, especially in the Me Too environment in general. The problem that we look in this space, which is particularly relevant, is this what we can call as a secure information escrow problem. That's a generic problem that I want to start with, which means that you want to allow users to encrypt or confidentially share their messages such that those messages can be only decrypted or will be available to the world in a user specified condition, and those conditions can be something which is chosen by user and can be checked by some kind of a program, smart contract, if something like blockchain is working. And in this paper, they talk about very interesting different types of escrows in this space, like commitment escrow, which makes sure that I myself commit that if I do this something wrong, then I should be held accountable and reveal this information. Posthumous shared interest, if there are some parties who have shared interests, that is looks very similar to in that space. But our focus will be today on the allegation escrow, which is exactly the topic where there is a particular kind of a crime has happened and somebody want to make an allegation, but they're afraid of making that information public. And that's the reason they are actually they want to make it public. And if there are more people who come into such a system, then they want to make it available. In such a system, we could say the parameters could be nature of crime, identity of the accused, identity of the accuser, text of the allegation that could be relevant, and as well as the interesting parameter threshold, which will be additional to kind of thing which was seen in the earlier court and is closely related to the matching algorithm from Scott's talk. And the ideas could be reveal information whenever there are at least 3 other people who have filed with the same allegation. And the interesting thing here is to make this parameter T a user choice itself. Uh, if you look at the idea is that you want to create a record of allegation that's created early on, accusers is guaranteed to collaborators. So there could be other set of interesting parameters that has to be considered when we build such a system. And Callisto is indeed an example of that kind of which provides a solution towards such a system. Uh, these are some of the statistics that we got earlier time. I'll be happy to get more updated statistics from them. This is old data, but I look forward to hear more information from Scott and others on this topic later. But if you look at the Callisto, at least the earlier version that we are aware of, it was only a single party. And in that case, this information is at least available at some point of time in plain text on such a server. And they must be trusted for its secrecy. A very interesting question did came in the talk, which consider what about auditing software and code, which can indeed improve the guarantees of that kind. But the question can be, I find this problem of secure allegation is to be a very nice topic for considering multi-party computation solution towards reducing the trust on the single server or single system to do the things correctly. And because there could be motivated adversaries who may have interest in that space, or possibly some insiders who can play roles or other in general, or journalists who can be looking for stories. So there are all sort of different aspects that one come in picture. And in that context, we wrote this paper, uh, which appear at NDSS, towards looking at the solution there. We can provide really good guarantees against such a system while still maintaining practicality of the solution. So a couple of disclaimer here that indeed many of the findings in this talk are a bit more academic in nature, but we'll be very happy to get feedback. And this is a problem which is quite interesting to me. And I'll be happy. You can reach out to me later, and I believe that there is a bit more work that can happen from academic side towards improving solutions of these kinds. And I look forward to hear from you. And this talk, many of the slides that I'm using also are coming from the student author who was Venkatarun, who helped us to build this system and also implement it. So now building the premise, as I already mentioned, there are 5 bullet points related to this: that nature of crime, identity of the accused, identity of the accuser, other details of the allegation, and a threshold in general. And we want to make sure that it's maintained. Such a condition is mentioned to make sure that only when there are T accusers, then the accusation get revealed to appropriate entity, to the attorneys or whatsoever. And in this talk, we want to make this problem a distributed problem so that no single server can obtain or know this information. So at least for this talk, we are going to assume that we have honest majority among these servers to make sure the information is secret. But I want to make sure that there exists a multi-party computation protocol where we can reduce this assumption. But there are some trade-offs which can be inherent, that if you want guaranteed inclusion of the protocol, then honest majority could be a necessary evil that has to go for into such system. And need not to say here, the idea could be then you have escrows, and these different entities all over the world can play role towards having some kind of a distributed service. It doesn't need, I'm just giving an example over here. It could be also restricted to one country, or there could be different kind of access structure that can be built for such distributed entity itself. How to build this distributed entity can itself be an interesting problem and interesting discussion topic itself. And so now that I build up this thing, I want to say that what is the core requirement that we have in such an environment? So when an allegations are revealed, so let's say there are a set of allegations, let's say saying that set as S, they're revealed only when all allegations have a threshold which is less than S. Otherwise, they are not revealed. So the key thing I want to add here, what is this threshold mean? That it's the one idea is to just say that there are 2 allegations and we immediately reveal it. But there could be situations where some of the allegers may not be comfortable just making 2 as a parameter, and they might want to go for a slightly higher parameter or somewhat higher parameter to make sure that they could to deal with all sort of different attacks, like somebody creating identities or just probing attacks. They might want to go for a higher number, and we want to provide such facility. But at the same time, it should not be the restriction that everybody follow the same threshold. User may or alleger may be comfortable to make their own choice, and the question is that how to allow such a choice is the thing. And let's say here we have a simple solution. Let's say we have accuser and they have put their reveal threshold to be 2, and then we have second allegation and they're accusing Bob and the reveal threshold is again 2. Then we are going to say that yeah, the matching has happened and this can be revealed. But let's say now we go to the scenario where Bob actually, for this alleger to be, they put the threshold value to be 3. And in that case, we do not want to make sure that any such revealing should happen, because the threshold that is set as by the alleger B was actually value 3. And let's say now we come across a third alleger C. Even in that case, we want to make sure that the reveal threshold that they put is higher, let's say 5, then we do not want any revelation to happen in that example, because the value is certainly much higher. And eventually, let's say it happened, we get a third alleger now, and they put the threshold to be 3. Now we can see that there are alleger A, B, and D, they all have matching thing, and only in that case we want to make sure that the reveal happen. But in that case also, it's important that the alleger C's threshold is still not made, so we do not reveal their identity into such an environment. So this could be a mechanism where we allow more complex matching to happen. And irrespective of the multi-party computation, this mechanism can be interesting to Callisto as it is to allow more complex mechanism, because it's a purely algorithmic approach to consider and allow such a system. Now, what has happened in this space in general? So, Callisto project, at least when we started to work in this space, was is a single party solution. But there was a paper that got written towards improving that to some extent and having better entities. But it certainly is a much weaker threat model that has built into. I really do not have the detailed knowledge inside how the Callisto's current approach is. If they can make their white papers public, that can be really helpful in that space. But at least in our paper, as well as other papers that got have written recently in this space, which are the listed here, do talk about the issues with at least the approach that is presented into that article written in this space. And along with this, there are like Hutu, Hutu plus plus and Shield. All these different algorithms have been worked out, and which of them have interesting positives and negative. What we realize over the period that it's a quite complex problem with very interesting parameter space to deal with in terms of the privacy as well as the scalability. And each of these paper offer different adversarial model or different threshold structures for the MPC, as well as different scalability thing in general. But what we observe, and the key parameter that we went for when in such a design, is that we want to make sure that the process doesn't become extremely cumbersome and it's scalable, even when the number of allegations are growing fast and is a significantly bigger number. If it is a situation that the number of your complexity and of the system in terms of computation grows linearly with the number of allegations, that can become a significant challenge as the system become more and more popular. And user may feel very uncomfortable where they submit something and may take a lot of time for them to get answer, and it can be a usability issue itself in general. So that's the reason when we build our approach, say, we found the scalability to be an important problem. So this is a generic MPC problem itself, but generic MPC, Hutu, as well as Shield, all of them required O of M computations where n is the total number of allegations that are already present in the system whenever we add a new allegation and we run the matching system. And that can be certainly susceptible to DOS attack, where some people want to just slow down the system, and they can do that very easily in this approach. And what we wanted from beginning is that we wanted an approach which is indeed much more efficient, so that we can maintain the scalability of such a system, assuming that we have a large allegation pool. And there could be other things which wanted to give importance, that there can be cover traffic to hide the timing channels, or as well as the users have anonymity using possibly Tor or other anonymity solutions. So now building some of the things, so we want to make sure that we have real identities are important, and reveal the allegers identity only when there are other appropriate things get revealed. But it's important that correspondingly some kind of identities of the user get assigned to them, so that eventually when the allegations are revealed, that attorney or some mechanism can contact them. And while doing that, we wanted to make sure that there are privacy needs that are mentioned. So privacy goals can be that the identity of the accused, identity of the accuser, nature of the crime, as well as other details, all are maintained private and possibly available in encrypted fashion or secret share fashion. Only the threshold is something that we find that keeping it public allows us to have a very efficient and scalable solution. Otherwise, problem becomes extremely complex and computationally expensive. And and in such a mechanism, we want to make sure that this accountability perspective reveal only and only if at least T people have filed the same allegation as the alleger in this particular example is something that we wanted. We wanted to make sure that no pseudonymous allegation and alleger need to have real world identities. That's a premise that required, but indeed some of the ideas from Callisto's existing approach could be incorporated towards identity and account recovery stuff, things like that. So working on making such a system can easily work with minority of escrows being malicious, and any number of users being malicious and try to actually figure it out, what kind of accusations are present on there, all sort of different attacks that can be possible. We assume that they use Tor or some kind of anonymity mechanism as well as cover traffic to stop the timing attacks inside a chat. So in such an environment, the idea is that there is some kind of a PK exists for the user, such that when user register into the system, they can get access to some key that can be very beneficial towards making sure that we can, when they later come back, that after registering, that they can indeed we can link them to their public key to their identity. But again, there could be interesting approaches that could be present, because this is closely related to the account recovery that we saw earlier. And as always, in such a mechanism, it's important that we use cryptography, which is efficient, and don't go for problems which can be otherwise very hard, like fully homomorphic encryption, and things can make a system completely impossible to work in a scalable fashion. So we wanted to avoid that. So those were the typical threat models and goals that we come up with in general. And the key goal is, as always, the scalability, and that the cost to file an allegation should be remain constant in such an environment. And that's the reason the idea is that you go for the solution which are efficient. The important thing is to have authentication mechanism in place for accuser, which is closely related to the account recovery and accounts in general, as mentioned in the previous talk. And we went for the mechanism of proof of identity, where we use a separate public infrastructure, which can be maintained by these servers or by an external entity, while maintaining the privacy of the user is what is available in the system. I won't be able to go through all technical details there, but please refer to the paper or contact me, and I'll be happy to talk about those in general. But we want to make sure that the identity of the user cannot be revealed by the minority of escrows until the indeed revealing condition are satisfied and maintained. Okay, so now let's start to look into this perspective. The basic could be like how we actually match allegations. There could be lots of complex issues there, because the allegations can be names can be different and can have different handles. So how to match them precisely certainly the challenge in this space. At least in this effort, we went for a simple approach, but how to manage the complexity of those things can be interesting problem itself. For example, there are two-part nature of the crime. So how to precisely describe that is an important thing, so that the matching algorithm can work efficiently, as well as how to really associate users to their identity is important. As Scott mentioned in his talk, indeed, the challenge can be names are quite difficult. So having social handles or email address can be much better mechanism in that, where we assign those as the identity for the accused. But at least for this talk, I'm just going to use name as a simplification or ease of expressing the things. But email or anything else can also work equally well in such a mechanism. The another thing could be there could be text of allegation, where you have much more details available, which are again revealed at the only when the appropriate conditions are satisfied. And there we can use basically secret sharing or encryption mechanism to achieve it in general. Now I'll be focusing, going a bit more technical detail and talking about how the matching works, at least in multi-party computation manner. And the key approach there is what is known as metadata. So we'll call the nature of the crime and the identity of accused as a single metadata entry. And the idea is to create an identifier for them. And toward that perspective, we use multi-party computation. Again, multi-party computation is again, just single slide for that is that you have data, we have value, let's say X and Y, and we want to compute some function on X and Y, but in a manner so that only nobody knows what is X and Y beyond what that function output says. And the idea is multi-party computation exactly solve that problem. This might just really couple of sentence explanation for multi-party computation, but you already have seen that in some other talks even yesterday. So hopefully that is sufficient. And then idea is that once we have such a shared metadata, we want to create a precise identifier for that. And we can just, if it is available in plain, we can just check it, but that's certainly not a privacy preserving way. And that's the reason then if we use a basic multi-party computation mechanism, we have to check that each of those entries equally, and that itself can become very expensive computation. So that's the reason we go for an approach which is known as PRF, or pseudo random functions. And the idea is that now we'll assume that this escrow will have some random secret that is not known to others and secret share between them. So it's random and even unknown to them. And rather than performing matching for individual messages or metadata itself, they do the matching now over the PRF computed on the metadata. And such that what's the property that we have with this PRF is that even when metadata 1 is equal to metadata 2, then the PRF output will be equal. But even in that case, we cannot take the metadata the PRF output and use that towards figuring out what's happening or what will the messages M1 and M2 will be. So the idea typically
just to jump in real quick, we're just running a little over. Can you just take 1 more minute to sort of wrap things up? We're just coming close on time.
Sure. Okay. Yeah. Sorry, I can't see the time. I should be done in 2 minutes. Okay. Yeah. So the idea is then you can compute these PRF values and the matching can happen. So when the threshold is 2, it's very interesting. But when the threshold is higher than that, such an approach can indeed work and allow things to happen in an efficient fashion in general. So because there could be maybe some interesting questions. So what I'll do, rather than going through all technical details, you can find that in the paper. I'll directly jump to the concluding slide to make sure that we have questions. Okay, let me just share this now. Okay, so there are interesting problems in this space from the future perspective. What we have allowed is to have a mechanism in place, but if required, if we want to withdraw or modify allegation, it's a very interesting problem in this space. Could be practically relevant because maybe the identity of the accused can change, and then what can we do about that is a very interesting problem. There could be more complex matching criteria which may require some kind of a machine learning mechanism, which could be interesting as well. And as well as let's say we have different thresholds for victims and witnesses. Let's say we have witnesses, we want to incorporate in such mechanism. How to do that can be very interesting. But overall, building such systems so that there are no security and vulnerabilities which are coming from software development is also interesting. But I believe that this is a very interesting problem where multi-party computation can actually allow really good solutions. And I'll be happy to have questions, as well as if you think there are interesting directions to work in this space, please do contact me. I'll be happy to get your questions. I believe this is certainly the problem where cryptography can indeed help towards introducing better or more trust into mechanisms like Callisto. Thank you.
Thank you.
Thank you. We're a little bit over time, so I think we only have time for maybe one question. I guess just before that, I did have a brief comment. So yeah, so I guess as someone who does work in this space, I think it is really great to see more people focusing on problems that do affect survivors, and for people to center the needs of survivors in technology. I did just want to make a brief note that I do feel like the language here does matter, and that we should reaffirm that survivors are believed, that they are not making accusations or accusing, but rather that these are the truth, like this is the truth, and that they are not necessarily allegations, but records of events that did occur. So yeah, just that's a personal note, I guess. And I did also want to just briefly apologize to everybody for not giving a content warning at the top of this session. So yeah, that was an oversight, and I do apologize for that. But we will open it up for one brief question.